Hey everybody, Mr. Rubo here. Today we're going to talk about complex numbers and mainly just what they are and how to deal with them. So the first thing that we need to talk about is what a complex number is. And so complex numbers come into play when we have a square root of a negative number. In particular, when we have a square root of -1, we represent that with the letter I. We use I for imaginary. So if you are, let's say solving this expression, and let's say we have, let's keep it simple, square root of -4. This is really the same as square root of -1 times square root of 4. Square root of -1 is I. Square root of 4 is 2. So the square root of -4 ends up equaling 2i. Usually we put the I at the end, but really it doesn't matter where you put it. So we're going to see this a lot when we're solving quadratics, especially because we're going to be taking a root. Excuse me. But one of the big things too to remember as you're dealing with complex numbers is that when you get I squared, that really means the square root of -1 squared, which means the square and the square root cancel. So I squared ends up giving a -1 answer. Okay, and it continues with the powers. You just think about what the power means, and it will hopefully explain how this works. So just to kind of see this, and it follows the same rules as like variables as well. So if you had 2 plus I, which we would call a complex number, plus 5 minus 3i, you can only combine like terms. So 2 and 5 we'd combine, but then the I and the minus 3i we would combine. So our final answer here would be 7 minus 2i if you were to add two complex numbers together. And by complex, I mean a number that has a real component and an imaginary component. Yeah. So complex are where you have both of them. Technically, one of them could be 0. So complex are really any number you could think of, including any number with I. Okay. So something that we will see this a lot with, an operation we're going to do a lot. Obviously, adding and subtracting, pretty straightforward. Multiplication of complex numbers. So let's say we have this, 2 plus 3i, and 4 minus 6i. So if we wanted to multiply this out, we'd multiply it out just like we normally would if it was a variable. So pretend that actually went to the right thing. 2 times 4 is 8. 2 times, ooh, I can't draw today. Whatever. So 2 times -6i is -12i. So we're done with the 2. Now we move with the 3i. So that would be, oh, that's interesting. Oh, I know why that happened. Plus 12i. And then last but not least, we deal with the 2 i's here. So it'd be 3 times -6 is -18, but then I times I is I squared. So now this is, we simplify the I terms, so they just have a singular I. So that means, in this case, they cancel. That won't always happen, it's because I chose specific numbers. I know that might be a little hard to see the yellow there, but that's okay. We're going to do the rest in black. Now this, the I term, I squared, we can simplify to -1. Okay, so that -18 and the I squared, well, the I squared becomes -1 because that's square root of -1 squared, square root and the square cancel. So you get that. So this becomes +18. This is canceled out because -12 plus 12 is 0, so we don't need the I anymore. Plus 8, so then we get 26 when we multiply this out, okay? And that's something we're actually going to see quite often, is the multiplication of these. But just realize if you're doing square rooting and you end up with a negative under there, we can now deal with it with this I term. If you already have the I term in the problem, the biggest thing to realize is if you are multiplying and you get an I squared, it does simplify to -1. So then you have to simplify that out, okay? So yeah, thanks for watching and have a good one.